All right, hello everyone, and welcome to another Stately XState stream. So, my name is David Khorshid. I am the founder of Stately and the creator of XState, and I created XState about, I want to say 8 years ago. And really, it started off as a way to express state machines and state charts in JavaScript. And then it evolved a little bit past that to be a state management solution for managing complex app logic. And so we're going to get into a little bit what that means today. I am going to be sharing this on YouTube, Twitter, and LinkedIn. So please, if you have any comments, then I should be able to see them here in StreamYard, and I will answer any questions that you may have along the way. The first part of this, it's just going to be a structured way of teaching you the basics of XState, so the principles of the actor model and state machines and state charts. And then I'm going to be answering questions and just taking comments and just talking with you all. So really, this webinar is yours. It's however you want it to go. So if you have any questions or suggestions, then please feel free to ask me. I see a bunch of people saying hi in the chat already. All right, so I'm going to, let's just jump right in. So I am going to go ahead and share my screen. And we, just like before, if you've seen the previous webinar, this is going to be the same type of app, but we're starting a little bit before we dive into the complete app. And this is going to be based on the feedback form. And so if you've looked at the XState, let me just pull up the link over here, the XState GitHub page, then you'll see that there are a bunch of templates and also examples in there. And I'll show those a little bit later on. And one of those examples is a feedback form. So we're going to be starting from the beginning and working our way towards there. So you know what? Let's just jump right in. This is, by the way, this is a React app running in Vue. But this tutorial is not, or webinar is not specific to Vue or React or anything else. Really, we're just using it to teach all of the principles. So the first principle I want to teach is actually the actor model, because XState version 5 emphasizes actors as the primary unit of abstraction, just like actors in the actor model are a primary unit of computation. And so what is an actor? And I'll just put it here. By the way, if you can't see the font size, please let me know. I tried to make it big enough so that we could see everything. So actors. An actor is, again, a unit of computation that has its own internal states. And so actors can also send events, which is a really important concept, or send messages, really. But in XState, we call these events. And an actor can also, of course, receive messages. And when it receives messages, it can change its behavior based on that message. So another thing that actors can do is spawn other actors. Now, this right now might be a lot to take in, but if you're familiar with state management libraries like Redux or Zustand, or if you're coming from Vue, we have Pinia, or Angular, we have NGRX, things like that, or even in other languages, you might be familiar with the concept of a store. And so a store, let's just make a fake one over here. A store is something that, has its own internal state. And, we could send it messages, and this looks different depending on which library you're using. But, this might be in Redux, you might have like store.dispatch, and then, you would dispatch something. Or you might even call some methods like store.addThing. But this is just a way of sending events to the store. And so what stores don't have exactly is a way to like spawn other stores. But really, stores are, just a, I guess you could call them a partial actor. So in XState, we also have these stores, but we have stores with superpowers. And these superpowers, like I mentioned, is You could spawn other actors. You could also do things like subscribe to these stores/actors. So they're really useful as a unit of abstraction. And so that's why we're going to start there today. So we're going to create actually a very, very simple store. By the way, I see there's almost 100 people watching. So, thank you all for watching. And so we are going to import from XState. And by the way, to get started, all you have to do is npm install XState. And if you're using something like React or Vue, you could install an adapter library like XState React or XState Vue, whatever you want to use. And that should be all you need. XState has 0 dependencies. So yeah, no need to worry about dependency hell or anything like that. So the first thing we're going to import, surprisingly to some of you, is not a state machine, but we're going to import from transition just to demonstrate what this actor model is. And so a transition function is like a reducer. If you come from the Redux world or similar, it's going to feel very, very familiar. So I'm just going to make const count logic equals from transition. And so the first argument is going to be our reducer function. We try to avoid using the term reducer because it's a little bit off-putting. And really, it is a transition function. You're given the states and the events, and your goal is to return the next state that follows that. So let's just return the states just to see what happens over here. And then the second argument for from transition is just your initial state. So let's say we have count 0. So we have a simple hello world component over here. And I'm just going to make a nice big h2 tag with count. And how do we get that count in there? So this is where an adapter library comes into play. But yeah, so I'm going to just import. And this is, let's see, what am I going to use? Use actor ref from XState React. And I'm going to show you how to do this using an adapter and also just using plain JavaScript too. So first, we make that actor. So, and we call it an actor ref because it is a reference to that actor, and you could pass it around in events and things like that. But count ref equals use actor ref counts logic. So this is your logic. This is logic that it's basically a fancy object with a transition method where you could instantiate an actor instance. So we could actually make many of these. So we could make another one. You know, we can make many of these actors. And so that's a distinction between an actor and an actor logic. So you can think of the actor logic like DNA, and then the actor as like an instance of that actor logic. All right, so now to read the value using this adapter, we could do this const count equals count ref, get the snapshot from that, and then read it from the context. And then we have the counts over here. So you're going to be able to see count 0 right over here. But that doesn't give you the most up-to-date count if we were to do something like update that count. So how exactly do we update the count? With from transition, this is just your typical, you could use a switch statement or you could use an if statement. And I'm just going to cheat and let Copilot do this. So we pass in an event object with a type. And let's say that this is increment. And then we're going to return the updated state. Again, this should feel pretty familiar. So now if we have a button over here, and this is an increment button on click, now we could send that count ref an event object with type inc. But you're going to see that this is actually not going to work. So we're not seeing anything. And that's because we're only reading the first, the first count value. So nothing is really updating, and it's not going to magically update for us. And this is on purpose. We don't want to have too many renders. We actually want to subscribe to get the value that we want, or to select the value that we want. So to do this in a React adapter, we would use selector, and then you pass in that actor ref, and then you pass in a way to select that count. And so you could do anything in here. Right now, we're just reading the counts from the state. And so now when we increment, you're going to see that that goes up. Okay, so how do we do this then without using a library? Or sorry, without using an adapter if you wanted to do it in vanilla JS? And I think that that's really important to understand. So I'm going to sort of cheat over here and put output, which is a nice, fun, lesser known HTML element. And so what we're going to do is we're going to just make an actor outside. So, and I'll answer all the questions in a minute. So const count actor. The way we create an actor is we have this create actor function from XState, and you pass the logic in there. Now from here, you could do a couple of things. You could subscribe to that count actor. So whenever it updates, you're going to get the latest snapshot. So const, actually, we could just do count actor dot subscribe, and then we get a snapshot of the state. And then, thank you, Copilot. What we could do is just read this output, and oh, it's expecting a string. Whatever, we'll just trick it. And we could directly set the output of the inner HTML to whatever the count is. And so now, remember, we're actually not using any of this at all. But now if we increment, let's reload. Probably won't work because we're trying to do something weird. But if we were to console.log, oh, I think this is because, I'm not sure. It should show it. Maybe I'm doing something wrong, but you know what? Let's do it another way. All right. Sorry, my mind is blinking over here, but ideally this would just output it to the output over there. We're probably just fighting with React or something like that, but that's okay. Or actually, let's do document.body.append child. All right, forget about that. So, and I'll show you how that all works later with vanilla JavaScript. But the idea, oh, okay, sorry, I know exactly why. Early in the morning for me. So we have to actually start the actor. So count actor.start, and then yeah, this button is connected to our other actor. So we're going to get rid of this, and then we're going to call count actor.send type inc. Okay, so now this will work. So now you see that we're incrementing it using vanilla JavaScript. And so basically, this is the XState API. You create your actor logic. So I'll just write here, create actor logic. Then you create your actor. Then optionally, you subscribe to actor snapshot updates. And finally, start your actor. And so that, before we even get into state machines, that is how you, that's basically the XState API, is those 4 parts. So I'm going to pause here for questions. I see there's 175 of you watching, which is awesome. So let me just pause and answer a few. See, hi, David. Thank you for this new webinar. I'm looking forward to getting a more deep dive into V5 actors. And that's why we're starting with actors today. Does the inspector allow binding in 2 ways right now? This has to do with the stately inspector, which we'll get into a little bit later. And it does not, I don't believe it yet. It currently supports 2-way binding, but that is coming in a future update. So Jeremy asks, do states changes cascade? If you could clarify that a little bit, I'd love to know what you mean by that. Let's see, counter goes burr. Yeah. Okay, so if you have a chain of relevance and something along that chain changes, do those changes cascade along the chain? So I think this might have to do with just derived state and things like that. And really, that's a pattern that you should be using anyway, is derived state. So by derived states, I mean that, like, let's say that you have a selector like this, and instead of doing something like keeping is count over 10 or something like that, you should derive that from your original state value. So is count over 10, and then this would just be like that. Or actually over here, you could even read it directly from the count. So you might not even use selector over here. You could just say counts is greater than 10. But just for example purposes, you could just use a selector there. Hopefully that's what you mean, but I'm happy to answer any follow-up questions to that. Let's see. CID correct. Would be nice to be able to pass a possibly undefined actor to use selector to be able to have conditional actors. I found a workaround by Matoush, so Andres in the thread. We'll get into that later, but long story short, you can do that already. All right, I'm coming in late. I'm thinking AI contexts as state change machines. All right, would love to hear more about that. Okay, so let's get back to our, our actors. So you see we have from transition here, and this implies that there might be other things, and actually that's true. So transition functions like this, of course, are not the only way that you could express logic in XState. So there's a few other ways, and I'm just going to show you another one of my favorites here. We have let's call this promise logic, and this is just going to be from promise. And of course, we have our async await function, and then you could basically do anything here. So we could const result equals await new promise, and we're just going to make a fake one over here that resolves with done after 1 second, and then we could just return that result. So this is just like you would write any other promise. In fact, if you got rid of this, like this is essentially just a promise. All we're doing is wrapping it in from promise. And why are we doing this? So that this promise logic can be used as an actor too, and it has the exact same interface and the exact same abstractions as any other actor you would create. So I'm going to take this promise logic, and we're going to do the same thing over here. And so let's see, I'm going to call this promise. Actually, yeah, we're going to call this promise actor. And we're going to use our promise logic instead. And so now you could see that we don't have context on the promise. Instead, we have an output, because actors can finish, and when they're finished, they could have some sort of output value. Let's just make sure that's a string. Okay, so you see that it starts with undefined, and then it goes to done. We could sort figure with that. There we go. And yeah. We could also say that actually, this is going to automatically infer just, or it should, actually it doesn't over here. But we could say promise string if you're using TypeScript, and then this should be, actually, I think it'll infer all the way through if we just use string over here. But regardless, now you're going to see that the output is going to be typed as string or undefined. But anyway, that's how you would use promise, promise actors. But yeah, so there's other ones. So there's observable actors, and there's also event observable actors and callback actors too. We might get into those a little bit later, but I think that it would be really good to start with actual state machines, because state machines are just another type of actor logic. So like I mentioned earlier, we're going to be creating a feedback form. And just to give you an idea of what this should look like when it's done, first, I'm going to just remove all of this. And we have an app final. So I'm just going to show you the end result first, and then we are going to take a look at basically how we can make this. Okay, so this is our feedback form. And you can imagine building something similar to this, something like a multi-step form or something that has many steps in its process, whether it's in the front end or the back end. And even in the front end, like having something that has multiple steps and representing it as an array might not be satisfactory, because you might want this to do different things depending on which step you're on, or what actions the user takes, or what events happen. And this is actually a pretty good minimal example, which is why we use it for the templates in the XState repository. So this is a sample feedback form. How was your experience, good or bad? So if you click good, it says thanks for your feedback. We could provide more feedback. If you click bad, it takes you through a different flow. So you click bad. Now we have a form over here where like, what can we do better? Show more state machines. I don't know. Reduce the learning curve, which is what I'm really trying to do here. And then we could submit that. And then we have thanks for your feedback. And I think you saw over here that, you know, if we were to reload this, that this is going to be disabled if, you know, if we don't have valid feedback. So basically, if there's nothing there, we forgot to trim it, but that's okay. We could go ahead and do that later. So that is what we're going to be building. And I really want to start from the beginning here. So I am just going to remove a bunch of stuff, and we're going to start from the beginning. So let's see. We are going to just take this form. That's all I want. All right. So, oops, sorry about that. Turn that. So I'm actually going to remove that and set that to false. And we're going to remove that. And this is just to show very, very simple example of, you know, using a state machine and how to do it so that, you know, things don't get too scary. All right, so I'm going to delete a few more things. And yeah, we'll delete that too. Okay, so just like the other types of logic, a state machine, in fact, you know what? I'm going to open a TL draw just to talk about this. So we have, you know, of course, different types of actors, or sorry, different types of actor logic. We have promise actor logic, and we also took a look at transition actor logic, which is just like a reducer. And then we have state machine logic. And so all of these actually do, you know, different things. So, oops. Okay, yeah. So these are all actors in the sense that they could receive events and they have their own internal states. However, a promise actor does not, so it does not receive events. It just starts off immediately. A promise actor also, you know, just eventually resolves with one value. And so this, you know, it might never resolve, of course, but eventually it's going to only resolve with one value, and it can't yet spawn other actors. So transition functions, on the other hand, these actually can receive multiple events, and they don't resolve with one value. They're just continuous. So I'll just put continuous doesn't finish, I mean, it might in the future. And of course, this can't yet spawn other actors. And so with a state machine, you have basically it's you have a lot of things. So it could receive multiple events. It can finish. It can spawn other actors. So there's, basically you could see a state machine as a superset of the other types of actors or the other types of actor logic. Now, of course, if you don't need all of the features of a state machine, then I really recommend you to use some of the other, actor logic creators that are available, such as promises, transitions, observables, callbacks, etc. All right, I'll pause here for questions before we dive in. All right, Javier says, now that everything is an actor, what would be a good criteria to either go for combined work of actors versus a state machine invoking actors? I think this is a really good question. And Javier says I answered this in TL Draw, but still the distinction is important. Basically how, when would you go from a single actor to like a multi-actor system? And the sort of cop-out answer is it depends. But the analogy that I like to give is it's sort of like being in a work environment. Like, let's say that you're a manager who's technically skilled and you have a big project that you want to do. You could do all of the work yourself. Like, there's nothing wrong with that, but that can get very complicated very quickly and it could overburden you. What you could also do is just have a team of, a handful of developers and other people who are helping you out to perform this project. Now, the problem with that is that it also introduces other complexity too, because now you actually have to sync up with them, have meetings, make sure that they're doing the right work, coordinate with them, have them coordinate with each other. And so even though you're reducing the work burden on yourself, you're creating a new work burden. And so there's this point where the benefits outweigh the drawbacks to that. And the same thing with the actor model. Just like you don't want your app having like many like microservices, there are an appropriate amounts where you're like, okay, this does introduce some complexity in the message passing between all of these little actors, but it is manageable compared to the alternative of having a single monolith and having that try to coordinate everything, because then you could get into things like race conditions and other things like that. So I like using real world analogies, and I think that makes a lot of sense when trying to determine whether you should use a single actor or multiple actors. But I would say to start off with, always start with a single actor. Let's see, Nicholas asks, do snapshots of promise actors have a state prop? Like, do they have pending, done? Yeah, so I'll show that in a bit. Please remind me, but snapshots do have a status property where you could see whether they're active or they're done. Yeah. Let's see. Hyder asks, are XState and effects.ts interchangeable? So this is a good question, sort of common, but they're not interchangeable. You could think of effect as like the missing standard library for TypeScript, and XState as a way to manage logic and actor logic and complex state management and state machines and things like that. But I like to say that effect is useful for the effectful parts of XState, and XState is useful for the overall structure. Eric asks, can we call a collection of actors a troop? And Elias asks, what are the optimal way of sending events to child actors and accessing their context? What about for a grandchild? That's something that we're going to talk about in a bit too. But we're starting like here from the beginning, as if you don't know XState at all. Okay, so let's actually create a state machine. Now, state machines sound really, really scary and complicated and everything like that. But honestly, the simplest state machine is a state machine with a single state. And so I'll show you over here to create a state machine. I'm going to remove these. We import create machine from XState, and actually XState has a better way that we're transitioning to, which is called setup, which in fact, let's go ahead and start with that. So if you're used to create machine, let me show you how to, transition, no pun intended, from that to setup, but we'll start with that. So const create machine, or sorry, const machine equals, and we'll call this feedback machine actually. Machine equals create machine, and then we put in an empty object. This empty object is the simplest state machine that you could represent. It's pretty useless. It doesn't do anything. When it receives events, it doesn't change its state or context. In fact, it only has basically one state. So this machine is extremely simple, but also extremely useless. So let's make it a little bit more useful. And we're not even going to get into finite states just yet, even though Copilot really, really wants to. So we are going to give it context. And this context is just data that is not really a finite state. So just basically non-finite data that you might want to represent in the state machine. And so these are things that could be like feedback, counts, user data, etc. But I would honestly start here. So before we even dive into finite states or anything like that, we have our context. And so we have feedback. It's an empty string. And now we need a way to update that feedback. So we could have an object with on, and let's have an event called feedback.update. I mean, you could call this update feedback. You could do like feedback, whatever you want. But when we update feedback, we want to actually change the context. And so the way that we do that in XState is through actions. So one of the actions could be assign, and then we assign to feedback. We're going to grab the events. And let's say that we get that from events.feedback. Okay, so this is our machine. And so we're saying that we're going to pass in, or we're going to send it an event. And this event is going to have this type. And it's also going to have a feedback property. And so we could use this assign action to update it. Now, something that's really, really important to note is that in XState, this returns an object that looks like type, xstate.assign. It might have assignments. And so it sort of looks like that. The assign function doesn't actually do anything. So we could even call this update feedback, and we could say const update feedback equals, and then we just pass it that assign function. So this is going to be an action object. In version 6, we're going to be making this a lot simpler, by the way. But just to show you how it currently is, this returns an action object that tells XState, here's what you should do. When you like when you get this feedback.update events. Okay, so let's actually use this now. And of course, you could do this in vanilla JavaScript. We're going to be using it in React just to make things a little bit easier. So I would say the easiest way to get started is with the use machine hook. I'm going to import that from XState React. You could see here. And this use machine hook is going to, just like use reducer or even use state, it returns a tuple where the first argument is a state or the current snapshot of the actor that's created by this. And then we have a convenient send function over here. Okay, so now we could actually, let's put this in the value over here. And this is just for explanation purposes. And let's actually give it some default feedback. I have no idea. Okay, so if we save this and reload, we see I have no idea. So pretty simple. Now, how do we actually update this? So we have this onChange property that looks pretty helpful. So what we could do is we could send type, and you'll see TypeScript isn't helping us just yet, but I'll show you how we could make TypeScript work for here. We send type feedback.update, and we give the feedback that events.target.value. So now you can see it's showing there. And actually, let's add a p tag and actually just show that state happening here. Okay, so you see we have our two-way binding, sort of. It's not really two-way binding, but you could see that we're sending events in the form of feedback.update, and it's updating like you could get it from state.context.feedback. Now, this this is just a really easy way to get started. So just like use reducer or use reducer, Redux, Zustand, we have a way of updating the value, or sorry, we have a way of sending events that updates the state of the actor from here. So yeah, let's actually continue with this, and then I'll show you a couple of other patterns. Again, I will pause real quick for questions. Nikita says XState is so impressive. It looks like it's possible to represent anything with it, especially when we use actor composition systems, but how to correctly distinguish what should be there and not. Okay, really good question. So I get a lot of feedback that even something like this can seem like overkill for app logic. And, sometimes it is. Sometimes, you might not have an app that has a lot of complexity, and you might not need to have a full state machine. I like to think of a state machine, or using state machines in XState, as basically like using an airplane. Millions of people use airplanes every day. But even more people use things like cars to get from one destination to another. Now, cars are perfectly engineered for when you want to travel, manageable distances that are connected by land. So if you need to go to the next city over, or need to go to the store down the street, you might use a car or a bike or something else. But of course, if you want to go from one continent to another continent, now cars become extremely infeasible. So really, you have to plan ahead and think, are you going to be developing app logic that is really complex in nature, or that might need that sort of structure? And it doesn't even need to be something that's really complex. If you want something where your primary method of communicating what's happening in your app is through events, then using an actor model is very useful. And you could even use it in simple ways. Like in this example, we don't need to use a state machine. We could actually use from transition, or we just actually released XState Store, which also really helps with this. So if we install XState Store, then this is another simple way of representing actor logic. And actually, I'll show this a little bit later. I'm just going to download it for now. But yeah, like it's sort of like a hammer. And of course, when you have a hammer, everything looks like a nail. You don't have to use it for absolutely everything. But the more you practice with it, the more it becomes a second sense where you understand, okay, this type of problem space is something where I will definitely need XState, or something like a state machine, even if you're not using XState. Jeremy says XState sounds like an object request broker. I used to be familiar with that term, but I forgot it. Extremely simple and extremely useless was my last performance review. It's great. Would you expand on how to compose XState state machines? Please remind me later, and I will. Let's see. Currently, it looks like a reducer without a switch statement. And yeah, actually, that's a very good point. You could definitely create your own state machine where you have just a switch statement, function feedback reducer, state event, and then you could like switch. But here's the difference. You're like, when you actually have a state machine, you're not switching on the events type, you're switching on the finite state value. But in this case, it would feel pretty similar. So we could basically create a switch statement like this, where we have feedback.update, and then we update the feedback. And you could definitely do it like this. The lines of code are actually pretty close to the same. So if you like using switch statements, you could do that. But there are benefits to having it in an object, which I'll get to pretty soon. Okay, let's see. Do I get it right that there is no way anymore in V4 to couple context with states using discriminated unions to enforce context having certain values in the certain states? this is something that we're still working on. It's a really hard problem, but we will get to it a bit later. But yeah, so before I answer any further questions, let's continue on with here and with what we have over here. So, okay, again, we have this very, very basic state machine that's not really doing anything special. And again, if you open the visual editor, you can see we basically have a single state and we have an update function that's all it's doing is really updating that state, or sorry, updating the context of that machine. So it's not really doing anything special. But if we want to actually make a multi-step form, this is where things actually get pretty interesting. So I am going to make a few states. And so the first thing that we want our feedback form to have is sort of this prompt state. So in prompt, it's just going to be asking you, was your experience good or was your experience bad? If it's good, then we go to a thanks state where we're just saying, okay, thank you. But if it's bad, we go to the form. And regardless of which state we're in, we could end up in a closed state. And so this closed state, we could also restart and just go back to this initial prompt state. And so that's why we're going to add initial prompt. Okay. So this is our very basic state machine. None of the states are connected, but you could see over here that that we have these 4 distinct states of our multi-step form. So if you could imagine the transitions, we have prompt, and when they click good, we go to thanks. If they click bad, we go to form. And in any states, they could close it. But especially in this thanks state, there will be a button where you could say, okay, thank you. And then you could just close that. And then from any states, we could go back to prompt. So since we're teaching XState, we're going to be relying on the code over here. Yeah, let's actually make these transitions. So we have 2 possible events over here. I'm going to let Copilot help me a little. We have on feedback.good, which the key of this on object is the event's type. So you can imagine that we're sending type feedback.good. So that's what that looks like. And then the same thing for here. So we're going to be sending an event object with type feedback.bad. The target is the states that we actually go to. So on good, we go to thanks, and on bad, we go to form. So just to show you what that looks like, now we have this. So on good, we go to thanks. On bad, we go to form, and then eventually we go to thanks again. So that's what our state machine looks like. All right. So on form, we could go back. So let's say for whatever reason you decided, you know what, I actually had pretty good feedback. It wasn't as bad of an experience as I thought. And of course, you could submit the form too. So submit, target, thanks. And then, basically on any state, when you close it, you could go to the closed states. But in the closed state, we could restart and go back to the prompt. Now, how do you represent that something can happen in any state? And before I do that, let me show you what this looks like. All right, so we have a better idea of, of our state machine. So we have our prompt. So when we have good feedback, it goes to the thanks states. And when we have bad feedback, it goes to the form, which you could also go back and forth between the prompts and the form. And then when you submit the form, it goes to the thanks states. And then at some points, we end up in the closed states. But we want to end up here from any states. And so this, let's collapse this for a minute. And let's add an on object. So on close. we're going to go to target. And because it's a child state, we have to start with the dot. So dot closed. And we'll get into parent and child states in a minute, but this is how you target that child state. Okay, so now we have a bigger state machine. And I actually want to show you like what each of the states end up being. So H2, I'm just going to show it here. And this is going to be state.value. And so it's a string right now. I mean, it might be something other than a string in the future, but it shows that our first state, we're in the prompt state. And so what we're going to do is we're going to be adding, just the different screens for that. So I'm going to cheat a little bit here and just copy and paste some JSX. So actually turn class name. Oops, no, equals feedback. And then we're going to, let's just put that prompt in there. I'm going to go ahead and delete what we did before over here. And so now you can see we have how was your experience? We have good and bad. Oops, not dib. And I'm actually going to show what the state object looks like. So to do that, I'm going to use a pre-tag. And we're going to just JSON.stringify the state just to show you what we're actually working with. So we have our value, and the value is prompt. And that comes from us being in the initial state, where the initial state is prompt. You see there's a couple of other things here. The two important ones are value and context. And in fact, let's set this to an empty string. Okay, so and let's reload that. There we go. The other ones we're not going to worry about yet. They're useful, but you might not need to use them for most use cases. These are going to be the two that you're going to be most concerned with. Okay, so now we want to transition states based on whether it was good or bad. And to do that, again, we have our send function. And that send function allows us to pass an event object. So for the good button, we're sending this event object with type feedback.good. And over here, it's type feedback.bad. So if we click good, you could see we don't have the screen here, but the value is thanks. So we transitioned from the prompt to the thanks state. And if we click bad, you see that we transitioned from prompt to form. So a useful way to conditionally show or just do something based on the state value is this states.matches function. Now, you could do something like states.value is prompt. And that is actually going to work pretty well if you have a normal state machine. But XState allows you to go a lot further and have states nested within states, nested within states. So the it actually might look like prompts and a child state and a grandchild state, and all of a sudden it's no longer just a string. So that's why we use matches over here with prompts. And so that way we could do something like, I'm just going to copy paste. Let's have a little thanks area over here. So if the state matches thanks, then it will just say thanks for your feedback. So if I click good, it shows thanks for your feedback. And so one question that, if you're coming from TypeScript, you might be wondering, like, how do we actually get this to autocomplete? Because by default, it doesn't autocomplete. This is why the setup function is useful. So to convert, all you have to do is add setup from XState, add an empty object, and I'll show you what goes in there in a minute, but this is actually going to work just fine. And then you create a machine from your machine setup. And setup is where you set up things like actions, guards, delays, all of the fun things that make your state machine actors actually useful. But now you're going to see, let's see if this works. If I type here, it actually shows our options. So we have closed, form, prompts, and things. These are all of our states. So I could just pick one and it auto-completes just like that. So hopefully, like this, right now, this gives you a basic idea of using a state machine for a multi-step form. And there's still more that we need to do, but I'm going to pause here for any questions. So let's see. Javier says, I've applied state machine patterns such as debouncing and throttling. Credits to Baptiste Devassier, a really awesome person, and his examples. Is there a plan on adding additional pattern abstractions to the actor methods? This is something that lives in userland, but I could see us adding helpers for that. There's a lot of patterns that you could use with actors. And in fact, actor frameworks such as akka employ these patterns, and it is a huge source of inspiration for that. Eric says the reducer is a state machine with a single state, one that just updates the context. The value of XState comes from not listening to certain events when in certain states. And yeah, so I do think that's definitely important. And if you wanted to make a state machine without using XState, you definitely can. In fact, just mention it on Twitter, and I'll probably link you to one of my articles I've written that's called I think it's called You Don't Need a State Machine Library, because you really don't. If you have like function feedback reducer, you have your state event, and you want to emulate this exact same thing, we could do something like switch on the states dot value, and then let's say it's case prompt. Then we could switch on event.type, and let's say that it's case feedback.good. So basically we could do the same thing. It's just that this is a little bit verbose, and this currently does not let you do this, which is actually visualizing the state machine. So I think that that's extremely useful. Just the ability to see, okay, here's how all of the states and transitions are connected. With an object, you could do that pretty easily. With a switch statement, not so easily, especially if you're trying to define your own state machine without any sort of patterns. And also, nothing here enforces the actual state structure of your state machine. It's just switch statements. Nothing is saying that you must use state.value and you must use event.type. So XState just provides a little bit of structure on top of that. And so, yeah, that's why it basically is just a reducer with a switch statement. But honestly, XState is a lot more than that. Hexymeter asks, do you have any example of what is the proper way to use this with React query? So one of the best parts about just the actor model in general is this abstraction that everything that can happen is an event, which seems like a tautology. That's literally the definition of event, which is something that happens. But if you have, for example, a use query over here, like const equals use query, and you have like your query over here, you could do something like put in your my favorite hook, use effect, and like if data comes in, you could just send type data and then just pass the data in there. And so everything is abstracted in this single abstraction called an event. And so, you don't have to hook any fancy callbacks or anything. Everything is just you're sending an event. And so that's how you could interact with use query, or really any library for that matter. Now, if you want to get more advanced, because of the different types of actor logic you could create, such as promise actors and observable actors and things like that, then it becomes very possible to, for example, in React Query, use the query client directly and just create actor logic from that. Alex says, thanks for letting us watch a nice presentation on a Friday morning. Absolutely. No better way to spend your Friday than listening to me babble about state machines and actors. But I really appreciate all of you being here. Jared says, so the setup function is really only needed for TypeScript and autocomplete, or is there a reason to use it when just in a pure JavaScript project? Uh, yeah, I'll talk about that little briefly, but we haven't really gotten into actions just yet. But the setup function is for setting up things like, not only just your types, but also your actions. So if we want to say update feedback, then we could do something like this, but also your guards, um, delays, and especially your actors as well. And this replaces the previous pattern in V4, where you would have this as a second argument to create machine. Because it's in a setup function over here, now we have really nice TypeScript autocompletes for that. And in version 6, this is going to be the way moving forward. We're not going to have those other options of having it as a second argument. So whether you're using JavaScript or TypeScript, it does become pretty necessary to have that up there anyway. So it's just something that is good to get used to. Okay, how do you use match in a case where two states have the same name but are nested so it's not very obvious at first? So let's say you have actually, yeah, that is a good question. You know what? I'll just show that over here. I know we're jumping a little bit ahead here, but this is good. It's a nice 2 or 3 hour workshop. So we're going to be diving into all the parts of XState. So let's say that we have an initial state of loading over here. And we have a loading state and a ready state. And so these are child states. So if you're new to XState and state charts, all this means is that you could have states that are inside of states. So, really good for organization and reducing the number of transitions. But yeah, so they were asking Darude Sandstorm, guessing that's not your real name. Let's say that we have a loading state inside of prompt, and we also have a loading state inside a form. So how can we do something like show a spinner? And I'll just have spin, spin, spin. How could we show this if we're in one of those loading states? So one thing that you cannot do is you cannot do state.matches like star.loading. That's not going to work. If you really want to match on specific child states, you could use an object and let's say prompt. And what's awesome is that TypeScript should, I have to do this. There we go. We have our states auto-completed there. So we have, prompt loading. And then we could show the spinner. So, yeah, and let's put this up here. Okay, so it is going to show spin, spin, spin. Actually, just for fun, we're going to, this is another cool XState thing. After a second, go to ready. Okay, so now it'll show spin, spin, spin for a second and then disappear. But what if you wanted to do it for this loading state as well? So these finite states can actually have tags. So, let's add a tag and let's add loading. That's just, it's sort of like a class name. So I'll just say this is like a class name. And so what we could do is put that same tag on this state as well. So this also has loading. And so that means that we could even call this something different. We could call it pending, for instance. And so when we call it pending, now let's say that we go to the, let's reload this. We see spin, spin, spin. And oops, that's supposed to go to form, but I don't think we have form yet in here. So I'm just going to go ahead and add that. But what I'm trying to explain is that you could actually, instead of having the state.matches prompt loading, you could say state.hasTag and then just pass loading. And so that way it's going to match any of the states that have that tag. So you see, we still match spin, spin, spin. And let me just add this form in here real quick. And I'll just get rid of these. So now, spin, 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 it's going to show that spin thing again because we were using the tag. And Baptiste says, thanks for making the webinar, David. Thank you all for participating too. Okay, so let's continue with our state machine. And so I'm going to delete the things from the previous examples that I just showed. Okay, so again, we have our feedback machine, and in this state, there's two things we could do. We could send feedback.good, which takes us to thanks, or we could send feedback.bad, which takes us to our form. So now let's actually get into that because it's something that we learned already, which is how to update context. So yeah, I am just going to copy paste our JSX from here because no one wants to see me type that all out. But yeah, so we have our text area, and just like we showed in the beginning, we have this onChange event handler, which grabs that onChange event, and it provides the value of that text area that we could just place right into the context. So again, we would go here, and now we have this on feedback.update, and this we're going to have an assign function. So actions, assign feedback, and then in here, just to do a deep dive on this assign, on this assign function, you could pass it either a partial context or you could pass in like the entire context. So now this starts to look like a mini reducer. So we could actually say return feedback. This is just going to be events dot what do we call it? Event dot value. And so what that's going to do, let's just show you over here. We're going to show the states.context.feedback here. And so now, just like before, we have the same, the same context being updated because we're sending those events, and those events are changing the context in the state machine. So yeah, let's just get rid of that. And yeah. So, oh yeah, I was talking about assign. So we have this, this events that we're passing in, and you could use assign as a function like that. What you could also do is assign individual context properties, such as feedback. And, we could just return. So real quick, over here, you get a few things. You get the context. You also get the event, and in more advanced use cases, there's other things you could use inside of here, but these are the two main ones that you would want. So over here, we could just return the events.value. And for instance, if you're adding to a to-do list or something, you might have like return context.todos.concat, like events.todo, something like that. But in this case, we don't care about the original context. We only care about the events that we're receiving. So another quick trick, I'm actually going to, just so that we could work on this state, I'm going to set the initial states to form. And so that way, when we reload, it's actually going to start in this form state. So now we could type things. We see it over there just to see that it is updating in the context. Although I guess we don't really need it there or we don't need it here because you could see it here. But you might have noticed in the original feedback form that this was actually disabled, if there was no context. So the way that we actually do that is by using what's called a guarded transition. And basically, you could think of this as a fancy if statement. But this guard basically prevents a transition from being taken. So in submit, we add a guard by adding the guard property, and then we grab the context, and we say we only want to continue if the feedback.length, let's trim it to, and yeah, we want to only allow this transition to happen if the if the context is greater than 0, like once we trimmed it. Let's see over here, I'm going to remove this. So now if this is empty or even an empty string and I click submit, it's actually not going anywhere. So, you know, it's not transitioning. This is one of the really important things about state machines, is that an event, if you send it, it's not actually going to do anything unless the transition can be taken. So this makes state machines really, really robust. So for example, if you're submitting a form and you go to the submitting state and the user, for example, if the button is not disabled and you click 1,000,000 times, it's not going to submit 1,000,000 times because there is no transition for that submit event. So nothing is handling that that submit event. So it's a really, really good way to, you know, just to make more robust application logic. So yeah, one of my favorite features of XState is that you could call states.can, and basically instead of saying like, or instead of duplicating logic and saying this should be disabled if state.context.feedback .trim.length is 0, etc. Like that is already encoded in the machine. Basically, what we're really trying to ask here is, are we even allowed to submit? So that's why the state.can, you pass in the events that you want to happen next, and we're disabling it if this event is not going to cause a transition. So of course, if we type something, it will cause a transition. So that's the magical thing about this, is that state.can is peering into the future. It's saying like, if I were to submit this event, will anything actually change? Like, is there any transition for that? And if there is, then that evaluates to true. If not, it evaluates to false. And so that's why, let's say that we're disallowing a bad word or something. So we could actually change the logic in here. We could say or context.feedback.includes bad. So if it has a bad word. So now my experience was really, really bad. Oh, maybe it's not includes. What was it again? Wow. But anyway, yeah, you could add other logic to it. Trying to think. Actually, let's get Copilot's help. Feedback includes string bad. Oh, yeah, it should. Oh, sorry. Should be an and. I'm sorry. So anyway, really, really. Oh, and it doesn't include bad. Wow. Okay, so really, really bad. Now that's going to, disable that. So now all of your logic is centralized in a single place, which is extremely useful. So if I save that, now we're allowed to do that. So yeah, one cool thing about XState, or useful thing rather, is that you might be wondering why this state machine looks very JSON-like. And that's because one of the goals of XState is for your entire machine to be serializable. And so what that means is that you could basically read it from a JSON object, or you could store it in a database, or edit it visually and things like that. And depending on your taste, it might actually feel a lot better than having multiple nested switch statements, or even worse, having this logic be all over the place. Now, because functions are not necessarily serializable, um, there's a way to actually specify this function in the setup and reference it later. So we could, I'm going to just cut this and say feedback valid. And so now we are going to add it to the setup. Feedback valid. And then I'm just copying and pasting it over there. So this, first of all, it will actually autocomplete. So if we have type and then press our quote mark, it says feedback valid. So we could actually choose that. So that's actually pretty useful. We could even do the same thing over here. So say update feedback. And then we could just have this as an action over here. Now, I actually really recommend that you stick with defining things inline first, and then once your logic is solidified, then move things out into setup, just because it's a lot faster to work with, just your state machine and defining things inside of there, rather than having to think like way ahead of time and thinking, here's all the actions we need, here's all the guards we need, because you're not always going to have all of that logic, all of that knowledge up front. So yeah, I will pause there for questions. So just reload this. Okay. Mohammed asks, is there any example repo for backend? And the answer is yes. If you go to just see how this works. Will it work? Okay, it will not work, but that's okay. If you go to the XState repo, and I'll actually open the screen to show you over here. Let me just go ahead and share the other screen so we could take a look at some examples. I have way too many tabs open, so this might take a couple seconds. Okay. So if you look at the XState repo, and let me just zoom in a little bit here. Actually, I'll just do this. Oops, not that one. This one. Then we actually do have an examples folder right over here. So if you click into examples, you're going to see actually a lot of examples. And there's many examples that actually start with workflow. And so these workflow examples actually run on Node. So they don't even run in a front-end framework at all. Of course, if you go to the ones that start with or contain the word React, then these all these are all React related. We also have things like Express Workflow that show you how to make your own little workflow engine in Express. But if you were to click into any one of the workflow files and then go to main.ts, then you will see the state machine in there. These are actually all inspired by examples from the CNCF serverless workflow specification. So we have our setup over here, and then we have some actors, and then we have our state machine. If you want to visualize these, by the way, and I actually just silently made this free, so you could just use it if you're logged into Stately. You could go from github.com to github.stately.ai. You might not see that there. So basically, I went from github.com to github.stately.ai just to show you in the text area. And if you do that and press enter on that file, you're going to get a visual of that state machine directly in Stately. So you're going to be able to just directly visualize that. Now, another way of doing that is you could actually just copy this raw file. So the entire file, you could go to states.new. And when you go to state.new, I'm just going to go ahead and import code. I will paste it in there. And then you'll see that we actually have our entire state machine visualized in here. So this is a simple backend workflow where we start in application, and then if it's successful, we go to the end. Otherwise, we go to reject. And there's also a guard at the beginning where you have to be over 18. Otherwise, it just immediately rejects. So this is one of the examples, again, from the serverless workflow specification. But yeah, so there's plenty of examples inside of the XState repository itself. Now, there's also templates too, and these sort of act as examples. So there's one for React, Svelte, Vanilla, and Vue. The vanilla ones, you could use those in the backends too. Nothing in XState ties you to the front end. So XState is completely agnostic whether you're using it in a front-end framework or library, or even in the backend. Doesn't matter. So yeah, hopefully that answers that question. I'm just going to go ahead and share my other screen. This code real quick. All right, let's find it. There we go. Okay. Can do this. All right, let's go to some other questions real quick. See, there's a lot of questions. Honor says, I often have actions to clear the context. For example, when resetting to an initial state. Is there any convenient way to achieve this, like a reset initial context action, perhaps? In XState before there used to be, but honestly, one of the simple things that you could do is this. So let's say you have your context over here. We could just move this up here. So context equals, and then we have that feedback. And then I'm just going to have this reset action over here. And I'm just going to assign that to context. In that way, we could have like feedback.reset. And this is just going to be actions reset or type reset. Again, the habit of making an action object so that we could add parameters later if we want to. But yeah, that's all you really would need to do for a reset action. And it could be done in userland or userlands. And yeah, so it's not something that's built into XState, but it is something that's simple enough to do. And actually, this is pretty useless over here. So I'm just going to move this right over here. And actually, let's add that to the form. It's a good exercise for like how you would do this in code. So let's say that I have a little reset button over here. So button and reset. Then on click, I would just send type feedback.reset. Thanks, Copilot. So now, let's say I'm typing a lot of things. I press reset, and it takes me back. Now, this is not a controlled component, which is why it's still showing here. But yeah, you can imagine if you did make it controlled, that's what you would do. So if I have the value as state.context.feedback, then you'll see that it actually does reset it. So yeah. All right, Dorit asks, what plugin do you use for auto-completion? It seems to predict what you want to type very well. So again, XState with setup will autocomplete, and this is just using VS Code and IntelliSense. It will autocomplete like your actions, your guards, and if you're using the setup function, it will autocomplete the value inside of states.matches. But for the things where it's basically magically telling you, oh, okay, this is probably the code that you want, that is using Copilot. So GitHub Copilot actually uses AI and LLMs to predict, what I'm about to type. And I want to let you in on a little secret, which is GitHub Copilot is really, really good at XState. And the reason it's so good is because XState has been around for 8 years. It's trained on all of the internet data. So it basically got a chance to read like thousands and thousands of state machines that people have created in XState version 4 and XState, I believe some in XState version 5 as well, like with the newer models. So yeah, go ahead and try Copilot. It understands XState pretty well. Baptiste says, XState being a big JSON object makes it easy to generate a state machine from other formats like nodes and edges from React Flow. And yeah, I actually really love React Flow, also known as XY Flow. It's an excellent way of creating these nodes and edges types of connected graphs. But yeah, I understand how the big JSON object could be off-putting, but really we're trying to find a universal way of defining these state machines, and JSON is really the closest that we could get. XState absolutely could have been made in some sort of dot chained builder syntax type of formats, but the problem with that is you lose things like bidirectional editing or the ability to just copy and paste state machine definitions even from other languages. So yeah, I think there's a good amount of trade-offs that we had to make when choosing JSON as a format for XState, but I'm pretty pleased with it. If you could just get over all of these little curly boys floating around everywhere. I'm sorry, we're not Python, so in JavaScript you have to deal with that. Nicholas says, I believe there are two main ways of doing XState in the backend. The first is through short-lived request response processes. That involves loading actor state from a database, hydrating, handling the event, and saving. And the other way is long-lived actors. And I think, yeah, that's actually a really, really good point. If you go to oops, I'm in the wrong thing, but there is an Express example that shows you how to basically restore the states, persist the states to something like MongoDB or even your file system, restore that state, and then continue the state machine from that state. And so your state machines could really be serverless in a way. Sorry. Okay. When we have nested states within states, and each can have its own context, how can one access the context from a deeply nested state effectively? So context, at least right now, is there's only a single context, and that is for the entire state machine. So there is no such thing as nested context, at least right now. So yeah, hopefully that answers that. Okay, so to get persisted snapshot to work properly, we should move the logic to setup. I had some problems using it with the cyclical structure. It should work regardless of if you're using setup or not. But I'm happy to answer any further questions in the Discord or wherever else. All right. Hey, Horatio. Good to see you. Any plans on Angular examples? I know that people do use XState in Angular. We don't have an official package just yet, but we do know that some people are working on that. So we'll definitely have more. And also, if you just do a search for Angular and XState, you'll see that people have made examples and even tutorials of how to use XState with Angular. One of the cool things about XState is that because this feedback machine, if you create an actor, so in fact, you get the actor from this third argument over here, you already have actor.subscribe. And so in this subscribe method, this actually implements a TC39 observable. So you could technically just use the actor directly in something like RxJS. And so that actually works pretty well. Andre asks, can you split a large state machine into multiple smaller pieces? Is it possible to have child machines? If yes, what are the caveats of parent state.matches, sending events, etc. So like I alluded to earlier, you could have nested states inside of states, and that's something I definitely encourage as your machine gets bigger. But doing something like, literally just separating this and having, let's say, const prompt equals like this object. The small problem with this, where you could definitely do this, especially if you're doing JavaScript, but developers tend to want the best of both worlds, which is you want strong typings here, and you also want the ability to like define this in a separate file. But that's extremely difficult to do because it is completely separate from something like setup, where you set up all of your types and things like that. Like, how do you connect the two? And sure, maybe we'll find ways in the future, but it just becomes a little bit difficult. So that's why, honestly, like code folding is your friend. But also, we're going to get into this in a few minutes. But you could also just have different actors, and you could encapsulate those logic into different actors, and then read the state from those actors too. Oleg asks, how to set state from a state machine from another state machine. The first machine is the main one. The second one is some sort of background processing can be which starts from the first one. So in general, I would answer this by saying that everything, like the only thing that could change states in an actor is an event. And that's why I love this mental model, because it's so simple. It's just everything is based on an event. So that event object, you send it, something is going to happen. Now, if you want some actor to affect another actor, the only way that could happen is that actor sends an event to the previous actor, and that's it. Now, with state machines in XState, you do have some nice affordances for subscribing to actors and updating the snapshot that way, if you want to. And we might get into that a little bit, but for most intents and purposes, you would just be sending events, and that's the way that you change anything. So really simple mental model, but it gives you a lot to play around with. It's sort of like Legos. Like, there's so many different ways you could put Legos together, but the concept is really simple. You have studs on the bricks, and they connect. Okay, so let's actually continue. Let's see. Where were we? So we have our feedback machine, good, bad, and we have our various states. So I'm going to get rid of this loading state for now. We have our feedback, or our feedback form, which has a prompt, thanks, and we also have a form. We have our reset button that we added, but we could just get rid of that. And yeah, let's also add one more thing, which is a way to basically close the form. So if let's just add this close button over here. So we go to feedback, and then we have a close button where we send this type close event. And so remember that this could happen in any state. So if we click good, we could go to close. If we click bad, we could also close it from there. Now, let's say that even though this is, and just to visualize it again, even though this is a, you could call it a universal event or something like that, basically this close event is going to happen from basically anywhere. So in any state, we're just going to say if the close event happens, then we go to the closed state. And this also teaches a little something about nested states, where depending on which state we're on, like let's say we're on the form states, the way that a state machine is going to determine which transition to take is it's going to start at the deepest child first. So let's say that we're in the form states and the close event happens. First, it's going to check this form's own transitions. So that would be feedback.update, feedback.reset, the back transition, and the submit transition. If any of those transitions are enabled by that event, it's going to take it. So for example, if we have the back event, then it's going to take this back event because that's enabled in the form state. It's not enabled in prompt or thanks or anywhere else, but only in the form state. This submit event, it's enabled in the form state only if this feedback valid guard passes. So that's why guards are so important, because they determine whether a transition is enabled or not. Now, let's say that we get the close event in the form state. So it's going to check all of our transitions, feedback.update, reset, back, and submit, and it's going to say, well, none of these transitions match. So then it's going to go up a level, and we're going to check the parent. We're going to ask the parent state, is closed, is it defined on your state? And it is. So it's going to go to closed. So that's why in any state, we could just go to closed. Now, if we don't want that for whatever reason, we could basically make a forbidden transition. So we could define a transition that does nothing. So let's say that we have this close event. I could just put an empty object over here, and that way, I don't know if you could hear, I'm doing a lot of clicking. Close does nothing. And of course, we could use state.can to conditionally show or hide or even gray out that close button, because it's not going to do anything. So that's how you could use basically that's how you could define a global, or not global, but a top level event, and also just forbid that event from happening in certain states. Okay, so let's actually get into the meat and potatoes of XState, which is actors, like we talked about at the beginning. Like I said, state machines can spawn and invoke actors. So basically, actors can spawn other actors, which could also spawn other actors. That's just part of the actor model. And so what I want to do is actually, instead of going to thanks, I want to create this submitting state. So submitting. And just to give you an idea of what this does, we'll make a little dummy UI to show. So we're going to go submitting. And I'm also going to add, let's see, state.matches submitting. And I don't have a fancy spinner or anything, but I'm just going to let Copilot do its thing over here. So now what we could do, submit some feedback, submit it, and then it's in the submitting state. So let's say that we actually want to submit the form data in this submitting state. Here's how we could do that. In the state, we could do what's called invoking an actor. So this actor could be a promise actor, it could be another state machine, but just to make things simple, I'm going to use a promise actor. So we invoke and we set the source to from promise, like we showed before. And let's just make a dummy thing like this. Return does. This is optional. Like it doesn't really matter what comes back from the promise. That is up to you and your logic. It doesn't matter. Okay, this is just because we don't have the latest XState. So PM state latest, which actually does solve this, and you could have inline actors in here, but yeah. So don't worry about that TypeScript error right now. This will still work. And then we could say on done, target thanks. So this is going to wait for 1 second, and then it's going to return this object over here, and then we're going to go to the thanks state. So submit, and then it says thanks for your feedback. And so that is a very simple way of just invoking something like a promise that might hit some sort of API and eventually return back data. So now let's say that we also want to simulate an error. So I'm going to add an error state over here, and TypeScript's freaking out. That's okay. State.matches error. And we're going to say that, something went wrong. Sweet Copilot just read my mind over there. And so one cool thing you could do is, because everything is in events, and that's the thing that changes states, we could say after, let's say our timeout is 2 seconds. We could just target the error state. So let's say this takes 3 seconds. Bad, feedback, submit. All right, something went wrong because this was taking too long. So now let's bring this down back to 1 second. And you could see that, it's actually going to go to thanks for your feedback. So that's another thing I want to quickly talk about, is that in XState, you could define what's known as a delayed transition. So you could say after 2000 milliseconds, we go to the error states. This is technically the same as doing this on, and then we have a special events that's like xstate.after.2000 or something like that. The details of this aren't important. Just know that it is a unique state. I think technically it's also like feedback.submitting. Like, it's just a unique event for this. And then we go to target error. But also what it's doing is it's going to entry, I'm just going to say it's going to tell XState to send that event after a delay. And then on exit, it's going to tell XState to cancel that special event. And so that's what's happening behind the scenes. But as a convenience, we have this after. And that is why when we're not in the state, so when we're not in the submitting state, and let's say that we're in thanks, first of all, the timer is canceled. But even if it weren't canceled, nothing in the thanks state handles that event. So basic principles of state machines, only defined transitions will cause an effect in a certain state. So yeah, let's abstract this a little bit more and show you how to use it in setup. So we're going to add an actor here, and this is going to be send feedback. And then this is going to be a promise, and that promise is going to call a fake API. And so now when we go back to here, we could autocomplete this to send feedback. So again, this is going to work. And then it's going to say thanks for your feedback. I'll pause there for questions if you have any. Let's see. Javier says, I want to mention that the actors on, done, and on error allowing arrays of actions with guards saved me a lot of time thinking about fallback setups. Yeah, so that's something that is important to keep in mind, is that you could have arrays of actions. This might be simplified in XState version 6. We're starting to plan that. But with actions, like currently, let's find a good action over here. All right, so we have, let's say that we have type update feedback over here. It's plural, and plural implies you could have more than one, which is absolutely true. And so we could do something like I don't know, console.log updated feedback. And so you could have multiple actions in here. We could also do things like raise events and just things like that. But yeah, you could definitely just have multiple actions in there. Currently in XState version 5, by the way, there is a slightly more convenient way to define multiple actions, and especially actions that could conditionally happen. And I feel like it's more natural. I'm just going to make a silly example over here. It's called onQueue actions. And with onQueue actions, you get this cool onQueue function that's a little bit hard to type, or at least to me, it's like all these weird U's and E's. And then you could on queue, actions like normal. So we could have TypeScript coming in clutch here, just in action. You could also just on queue an assign action. And so that's going to work, pretty naturally. You could also have conditions too. So if, let's say we're reading context over here. So if context dot feedback dot length is greater than 0, then we could on queue like a send to. So we could do things like this. And this becomes a more natural programming model because, it feels like you're imperatively executing these actions, but because it's called on queue actions, it's basically saving those actions to be executed when the interpreter actually decides, okay, these actions need to be executed. So yeah, if you want more dynamic actions, look into on queue actions in the documentation. And so the documentation, if you go to statelead.ai/docs, you should find absolutely everything there. So yeah, in short, you could have multiple actions. Okay. Baptiste says, delayed transitions are one of the best features of XState. It makes managing timers so much easier. Thank you for that. Yeah, if I have time, there's another example where we could actually make a timer with XState, or I could actually show some of the examples there. Honor says, sorry if I missed it, but is on queue a bit like Pure? Yeah, so in XState version 4, we have this awkwardly named function. And I say awkwardly because it's my fault. I'm the one who named it, called Pure. And so Pure allowed you to return an array of action objects. But onQueue is a more natural form of that because you're onQueuing whenever you want. So it's doing what Pure does behind the scenes. It's just a little bit easier to use. And Baptiste says, onQueue actions, I love that the stately team added this function. It's way better than Pure. So just like I mentioned, it's basically doing the same thing, just in an easier way. Thomas says, is it possible to split the actions in a different file? Do you think it's a good idea? I think so. So and that's actually a really good segue into this next part, which is using parameters or parameterized actions and guards and things like that. So let me add some types here. And by the way, everything that I'm talking about in here is in the documentation. So let me just add feedback string. Okay. So let's take this guard, for example. If you define the guard inside of here, we have context. And the context is strongly typed to have feedback as a string. So then you could call context.feedback.trim.length 0. Let's say that you actually wanted to define this in a separate file. And by separate file, I'm just going to put it at the top here. So we're going to say, what's it called? Feedback valid. So const, actually, let me scroll back up here. Feedback valid equals this. Now, there's a little bit of a problem. If you define this in a separate file, you need to know what this context is. It might not be that big of a deal because we could just type it context, type of context, and then everything should be, oh, well, it's the same name. So let's call this initial context. And then we could call this type of initial context. So you could do this, and TypeScript is happy. It says, okay, I know what the type of the context is. Everything is typed. But then if you get the events and everything else, then things become a little bit trickier. So there's actually a different way called parameterizing actions. And this is probably going, actually, this is definitely going to be the default in XState version 6, where instead of providing the entire context, only provide what the actions need. So the way we could do this, and which makes it really easy to define actions and guards and actors in separate files just actions and guards in separate files is to provide parameters. So I'm going to define my parameters, and I'm going to say all I care about is the feedback. Then we could just say params.feedback.trim. Don't worry about this. It's just TypeScript being really, really annoying, but we're ignoring that first argument, and then we're saying we only care about the parameters. So now, how do we actually bring those parameters in? So see, we have feedback valid over here. So now we see that we have an error over here, and that's because there's a nasty TypeScript error. We're missing parameters. So now we could say that our parameters, and we could pass in the function here and grab the context, and then we could just give it the feedback from that context. So basically the guard or the action, wherever you're deciding to use parameters, is only declaring what it needs. It's not saying, give me the entire context or the entire events, because that is implementation specific to the state machine. And actions and guards, really, they should just be simple functions that a guard should return true or false, and an action should just do some sort of effect without having to care about everything inside of context or events or anything like that. So that's why I prefer to use parameters. It just provides a really nice separation between, just between the different ways of like separating out your actions and your guards. So, okay. Let's see. Paul Shetstov, sorry if I mispronounced your last name, asks, what is the difference between actions and effects? So the docs explain this too, but actions and things like invoked actors, both of these are what XState calls an effect. And an effect is just something that happens external to the actor. And actions are fire and forget effects, which means you don't care about the results of them unless they're special actions like assign. So if you're doing something like do something and you're just doing a console.log hello, this doesn't affect the machine at all. It is a fire and forget side effect. However, if you have an actor like send feedback, then it's something that's managed by XState. So XState does care about, for example, what the resolved value of this promise is. Or if it's for an observable or something else, then it does actually care about, and it still has this connection to this long-lived effect. So in other words, let me just open TL draw. You could think of an action. So this is an action where, let's make this black. So an action is like this fire and forget. So fire, forget, effect. Now, an actor, it's a little bit different. So an actor, it's not fire and forget. So actor, it might return things. So it might send events back or be managed by the parents. So managed by parents. So hopefully this distinction makes sense. But overall, all of these, wow, that's terrible, are effects. And so effects are just things that happen outside the actor. Hopefully that makes sense. All right, and thanks for the explanation. Okay, so now let's get back into actors. And this is where we're actually diving deeper and deeper into XState. So, just like before, we have this from promise actor. And right now it's not really doing anything. It's just setting a timeout and returning a status. But what if we actually wanted to return the feedback? So the way that we could do this is by declaring input, which is a really, really good feature of XState. I sound biased, but you know what I mean. And so let's have feedback as a string. And so this is how we type it. It's going to be destructured from an object, and then you could just say that the input is going to be an object that contains a feedback property, which is a string. So now, we could do things like console.log, sending feedback, and then this is strongly typed. So we do have this input.feedback, and you might call some sort of API. So you might await fetch, and then, some URL, and forgot that that's a thing. And then you just return, something like, did it work? True. I don't know. Just whatever you want to return over here, or feedback submitted, and then this is whatever. So basically, just whatever comes from that promise. This is implementation specific to your use cases. But now we have to actually specify this feedback inside of send feedback, and you can see that TypeScript is at least telling us, hey, there's something missing here. It's really a terrible TypeScript error, but you are missing input, which is why it's yelling at you. We do have to do something about those TypeScript errors. It's very hard to control what TypeScript tells you when something's wrong, but what we could do is we could specify the input property on the invoke object and say that our feedback, which is strongly typed, should come from context.feedback. And then what we could do, actually, let's do this. So I'm going to have feedback string and then received feedback, also a string, or we'll also make it null. So let's make our initial context received feedback null. And I'm just going to go ahead and move this back over here just to make things a little bit simpler. Okay, so our promise actor, eventually it will resolve, and it will resolve with our feedback. And this is something that we could actually react to. So we could have an action, and we could assign, and we could say our received feedback should be events.output. And this event.output is going to be the result of that promise. So our send feedback promise, we're going to have an object that comes back, say submitted feedback, and that should be strongly typed as well. So we have feedback submitted over here, and then we go to thanks. So now in our actual form, or sorry, not the form, but when we actually submit it, we see our state.context.feedback. Instead, we could have state.context.received feedback, or maybe it's missing, but because that could be a string or null. So now, if we type in some feedback, and did I put this in the wrong place? Yeah, I might have. Okay, so let's go back to our thanks state. Here we go. We press submit, and then we see submitted feedback, which comes back from the server or wherever. So if we just redefine this, just to make things a little bit more clear, and just do input.feedback.to uppercase and just make all of it just screaming at you. Bad. I didn't like it. Now it just screams at you. So this is what comes back from the server. So yeah, that's where things like input and output, which are just very related concepts, are useful in XState. So yeah, I'll pause there for any questions. And to drink water. Okay, let's see if there are any questions. Over 400 of you and no questions. Great, I guess. Okay, so I, I guess I could take this opportunity to dive a little bit deeper into state machines and more specifically state charts. So state charts extend state machines, but state charts are state machines. So they're basically the same thing. It's just that state charts are a way of specifying more complex state machines, but also a way of organizing it in a way that you don't have an explosion of transitions or a lot of complexity. It's a way to organize your states and transitions in a state machine. So, for example, let's say that our prompt actually had 3 different states, and so I'm going to just edit it over here. Let's bring this down a little bit so you can see. And then, yeah, let's change this up a bit. So let's say we have, see, how do I want to do this? Okay, so let's say that we have 3 different sub-steps inside of our step. So, we have step 1. And so I'm just going to call this prompt step 1. And then we're just going to copy and paste this. Just make this a little bit easier. So now we're going to have prompt step 2. And this is going to be prompt step 3. Okay. So then we're going to add some states over here. So initial step 1 states, we have step 1, step 2, and step 3. And then for each of these, we're going to add like the feedback over here is going to go to step 2, regardless of which one you choose. This one is also going to go to step 3. And then this one is going to go to either thanks or form. Let's see if this works. Let's see, what did I do wrong? Let's see. JSON. I really love using JSON.stringify state and then just putting it on the page, just because it's such an easy way of debugging these. And so if you're debugging your state machine, you could either log this, or actually I might be doing something wrong. Let me double check over here. Okay. So if you were to open this in a browser, you would actually see that it's going to tell you that some transitions aren't possible. So for example, thanks is not a child state of this prompt state. So in fact, if we were to visualize this, I'll show you the problem over here. It's not even going to visualize because, yeah. So what we could do instead is target these states by ID. And so to do that, just like in HTML, you would add the hashtag, £, whatever you want to call it, and also give an ID to these states. So if we go to the thanks state, give it an ID of thanks. And so now things should work. There we go. Okay. And now I'm debugging it twice. So let me just get rid of that. And so now we're in our prompt state. So good. And then it takes to thanks for your feedback. Then we could restart over here. And then so we could just keep going through all of those states. And so these are, I know it's a bit of a contrived example, but these are child states inside of that parent state. And this is what that looks like. So let's auto layout real quick. We have this prompt, and we're in this prompt state and we say, you know, we also start in the step 1 state. So basically, when you enter the state machine, it's going to find the initial state, which is prompt, and then it's going to find the initial state of that initial state. So it's recursive, and it's going to say, okay, we're on step 1. So why use nested states? You could use it as a method of organization, but also, like I told you previously, it does reduce the number of transitions. So let's say that in any one of these states, so step 1, step 2, step 3, they had a bad experience. And we want that bad experience, that events, to always go to the form, no matter which state we're in. So the way that we could do that is, let's get rid of these. And let's define this at the top level like we did before. So we have on feedback.bad target form. So now our state machine is going to look a little bit different. And let me just try to show this to you. Here's our form. And so now we have this feedback.bad. By the way, this is the old the old visualizer, which is why it looks a little bit crazy. Or there we go. Where is it? There we go. Feedback.bad. So regardless of which state we're in, so it doesn't matter if we're in step 1, step 2, or step 3, if we get this feedback.bad, it's going to take us to the form. And this is because of something we were explaining earlier, where let's say we're in this state and we get feedback.good. Then it transitions to step 2. But regardless, let's say that we get feedback.bad. First, we check the states inside. Like, did we get a feedback.bad event, or do we have a transition that is enabled by that event? We don't. So we're going to go up to the parent. Is there a transition enabled by feedback.bad? There is. So we are going to take that and we're going to go up to form. So the effect of this is that no matter which state we're in, sorry, that's a little big. No matter which state we're in, if we click bad, it takes us to the form. So that's one of the valuable things about having nested states, is that you don't have to have a transition for every single one of those child states to go to a specific state. Instead, you could basically say, or you could delegate that logic to the parent state. So I know that was a lot to take in, and honestly, having the more advanced features of state charts, such as nested states and parallel states and all of these other things that we didn't get to just yet, they're very, very useful if you have more complex logic requirements. They're not things that you should start with necessarily, because your logic might be simple and it might not need any of those complex things. You might just need a simple state machine. So I will pause there and go to questions. So it's a bit confusing that an action can assign a value to the context while being considered as a fire and forget thing. Honestly, this is because of XState tries to adhere to the SCXML spec, which is state charts for XML, which was made part of the W3C in 2015. So it's a pretty old spec. It was started even before then. And in there, an assign action is actually also an action too. So it is something that's in the executable content of a transition. So it's honestly just the most convenient place to put it. It's something we might reconsider in future versions, but for now, that's just a convenient place to put it. Paul continues to say, for me, an action is more like a thing to tweak the state a little, while a spawned actor is a thing that has been triggered by the machine entering a state. Am I correct? Sort of. So only the assign action would tweak the state a little. You also have actions that might not have any direct immediate effect on the state. And these would be things such as like a log action, a send to action, where you're sending an event from one actor to another actor, or even a raise action, which raises an event to be processed by the machine, which is pretty close to immediate, but it's still something that happens externally and then comes back to the machine. And a spawned actor, you could either have it, be invoked, or you could have it be spawned, and those do different things. It's more of an advanced topic, but yeah, there's a little bit more of a distinction. Uh, Daniel asks, is there a visualizer for VS Code for XState v5 already? And not yet. And so I'll talk about that a little bit right now. And right now, the extension, so the VS Code extension that you're seeing, it does work partially with XState v5, which is why we were able to get it to work right here. Now, the tricky part, and this is also a problem with the existing extension, is the bidirectional editing. So there's a lot that happens over here where, if we move things, of course, the code won't necessarily change except for this big ugly layout string. However, if we do things like add states, add transitions, then that's where we basically have to make surgical updates to the code. And this has actually worked pretty well, especially if you've been using the XState extension for a while. You already know that, for a lot of use cases, this works pretty well. But where it sort of breaks down is like if you want to do custom things to your code, like we talked about earlier, moving parts of your state machines to different files, even some of the actions and guards and things like that, because there's many ways that you could edit your code. But of course, in the editor, you have only a constrained way of editing the states diagram. And somehow both of those need to stay in sync. And to get absolutely every edge case working perfectly is a very daunting task. And so that's what we've spent a long time trying to make it work, just with all of those, regardless of if it's XState v4 or v5. It just took a lot of effort. And so if we are going to release a visualizer for XState v5, it will probably either be view only. So you could, visualize the state machine on the right, which is very useful. Or if you wanted to edit it over here and have it reflect back on the code, it's going to be more of a complete replacement of the code rather than doing surgical updates, just because that's going to be a lot easier to do. So yeah, it's still something that we're slowly working on. But yeah, it's definitely an extremely tough problem to solve. If you've ever tried to do bidirectional editing of diagrams in code, it's just, it's a hard problem. Thomas asks, can we replace a child state with an invoked actor? So you invoke an actor in a state. So they're not interchangeable. It's when you're in a state, for example, when we're in the submitting state, we're invoking an actor. And you could also invoke multiple actors too. So I could also invoke something else here, and do that. So that's why, you do have to have that invoke property when you're in a state. And Paul says, thank you, and maybe consider a read-only visualizer. I think that's what we're going to go for next. And yeah, I think that's a really good idea. Okay, so other XState concepts. I'm trying to think. There's honestly a lot to talk about, and there's not too much that we could fit in under 3 hours. But the basics, you could cover in 5 to 10 minutes, which we pretty much did today, which is how to create an actor, which is, just something that has its own internal state. It can receive events, and it can update its internal state based on those events. You could use from transition, from promise, and of course, create machine to do that. And then we're just diving deeper and deeper into state machines and state charts right now. So here's another good one. When we are going through this form, oops. So let's say we have step 1, step 2, step 3, and then actually, let's step 1, and we want to go back. So let's say we were in step 2, and we click bad, and then we go back. It actually goes to step 1, which is a little bit unexpected. And so that's where we could use what's called a history state. And so the history state means go to the most recently visited child of this parent state. So I'm just going to call this hist and type history. And so now when we go back, and this is also going to teach you how to target child states. Instead of going back to the prompt, which goes to the parent, we're going to target prompt.hist, which is that history state. And so that way, what's going to happen is, let's reload. If we go to, for example, step 3, and then we click bad, and then we click back, it takes us back to step 3. So just going to show how this is visualized. So it's a little bit crazy over here. So we have a history state, and we see that for our, sorry, let me just zoom in a little bit there. Okay. So in our prompts, we have a history state. In this history state, all it's doing is remembering which one of these child states we were in. So if we go back, instead of going back to the parent, which will always go to its initial state, we're directly targeting the history state, which will go to whichever step we were just on. So you're not going to use this all the time, but there are instances where using that is, really useful. And this is one of the original ideas of state charts, and something that's also specified in SCXML, which is why XState includes that. But honestly, most of the time, you will not need to use a history state. Oh, and that answers, wow, I read your mind. So that answers, can you talk a little bit about history states? Cedric asks, emit is also a really good thing to introduce in version 5, if I'm not mistaken. Yes, okay, so that's actually a new feature of XState version 5. Really, really good call. So let me go ahead, I'm going to undo this. And okay, so I'm going to sort of do this impromptu here, but I think that this is a very, very important feature. Let's call this function toast. So what we're going to do is we're going to make a really simple component that shows a toast when it receives, or let's, toast is a weird word. Let's call it notifier. And so this notifier is going to basically receive events and display them on the screen. So we're going to return div, and let's make this strong, and we'll just put example notification here. This is actually going to be fun, because we're not only going to show you what emit is and how it's super, super useful, but we're also going to be showing you basically how to work with these state machines and these actors in real life applications, and where you could express more and more complex logic in a simpler way. I didn't say easier, but simpler. There's a difference. Okay, so let's put this notifier on the screen. And it's just going to say example notification here. Make this a little bit bigger so that you could see it. Okay, so example notification here. And in fact, let's give it a little color. Not white. Let's make it just orange. So that's way too, whatever. We'll make it blue, even though it's not the exact same blue, but that's okay. We're just showing an example notification. And so let's say that we want to know when this form was submitted, but we don't really want to like be closely coupled to this feedback machine. Like all this notifier cares about is I received something, so I'm going to show it. It doesn't need to know about the feedback machine or any of these other actors. It doesn't even need to know about the actor model or state machines at all. So it's a really, really good way of decoupling. So what we could do is I am going to pass the actor. How should I do this? Yeah, you know what? I'm just going to pass the actor in here. And so because the actor is just an object, it's an object with a send method, get snapshot, all of that, you could just pass around this actor reference just like any other value. And so it becomes really, really useful that way. So this actor, really it's any actor ref, which is something that XState does provide you. So you do have that type and you could do whatever you want with it. And we could, let's const notification. We're gonna we're gonna use state here just because, you know, use state isn't bad. It is useful for simple use cases like this. This is going to be string or null. And so return notification, show this. Otherwise, we're not going to show anything. So now we have no notification, but we are going to receive it here. So now in a use effect, we could basically subscribe. So in like before this feature was released, this was actually a little bit difficult to do, where you wanted this actor to notify you of something or basically emit an event that you listened to and cared about. But this wasn't necessarily easy, or it meant you depended on the implementation details of that actor. So it was actually a little bit tough to do. Now with XState v5, there's a simple way by using emitted events. And so what you could do is say actor dot on, and let's say we have a notification. So now we have the event, and we could set the notification to the events dot. Actually, let's have it as a message. Okay. All right. So that's basically all you have to do. And this is a subscription, so you know, counts. If you really want to do the cleanup, which you should, it's a good thing to do. You could just call that, just unsubscribe to it when this component is turned off, so that you don't have any memory leaks or anything like that. Okay, so now how do we actually emit this notification event? Let's go to, we're submitting on done. When the form is submitted, we're going to do multiple actions. So one of them is going to be assign. The other one is going to be emit. And then we emit this type notification. And our message is going to be feedback submitted. Now, I am importing the wrong emits, which is why it's yelling at me. There we go. Okay, so we're emitting this event, notification, feedback submitted. All that this is doing is just emitting it to whoever is listening for it. So now let's actually try that out. Hopefully it works. Doing this completely impromptu, but it is a very, very important feature to talk about. All right, so let's say we, you know what, let's say we go through good, and it says thanks for your feedback. There won't be any notification because we didn't submit a form. We just said everything was good. So now if we click bad and we say something really bad and we click submit, you're going to see feedback submitted. So that's how you could use event emitters, or basically use XState as a very simple event emitter, listen for that notification event, and then basically consume this, you know, this event. So really, really useful. Okay, I will pause there for questions. And Cedric says that he uses this for notifications on his side. Yeah, please let me know how you're liking emit. It is a fairly recent feature. Javier says, I know you don't want to deviate to advanced concepts, but can you give an example usage case for spawned actors? Yeah, I definitely will. So really, there isn't much difference between an invoked actor and a spawned actor. They're both just actors. It's just the only difference is that an invoked actor is going to be stopped when you leave the state. That's it. That's the only difference. So it started when you enter the state, such as submitting, and it stopped when you leave the state. And just to show this in action, if I say on well, actually, we already saw this. So with the timeout, if we give this a really short timeout, then it's going to go to the error state. And because it left this state, this actor, this send feedback actor, is going to stop, which means that even if the promise resolves and it says, okay, hey, here's the resolved value, it's not going to do anything. Firstly, because we're in a different state where that event isn't handled, but also because we're actually stopping this actor with its custom stop logic when we leave the state. So spawning an actor, and I'll show you what that looks like, is different because you have to control when it started and when it stopped, and you could start it in an action. This example isn't really set up to do that, but I will show you how to do it. Let's just say I do it here. Actions. There's this spawn child action creator, and so you could give it a source, and so that source could be like from promise, and then that could be whatever you want. New promise. Whatever the syntax is for that. Yeah. So yeah, that's how you could spawn a child. Oh, it is also expecting something else. It's expecting like an ID. Or well, actually, this one is expecting input for some reason. But yeah, you could just give it input like this. Again, like I said, this example isn't really set up for spawning children, but it's essentially the same thing as invoking a child. And so you these spawned actors can actually also live in context as well, and you could just pass them around as values. If you do want to access them though, then they are available. So if we go back to the component, they are available in state.children. Whatever the ID of that actor is. So if we go to submitting, we could give this an ID of feedback promise or whatever you want to call it. And then we'll have state.children.feedback promise. And then you could actually pass this around. So you could say const output equals use selector, taking the feedback promise, and then get the the snapshot.output if that exists. So just to show you that that's working, let's go all the way here. By the way, this is all being recorded on YouTube, so if you want to watch all of this later, then please feel free to. So right now, it's not going to show any output because there's nothing coming from there. But if I reload this, bad, rar, submit, something went wrong. Oh, because we set the timeout. So let's bump this back up. Reload. Okay, so it should have showed some output, but it did not. Maybe because we're not getting output. But you know what? Let's go ahead and log date.children. Hopefully this will show it too. Okay. So this is because it happens super quickly, but there is children. It just it's deleted when when we're no longer in that state. That's right. So yeah, sorry, I was just trying to show an example, but a little bit contrived. I'm going to answer a few questions and then maybe we'll get back to that. So Daniel asks, did you try some fun with fine-tuning LLM to output XState? Like I mentioned before, OpenAI GPT 3.5 it already has extensive knowledge of XState, so there really is no need to fine-tune it. However, in Stately itself, if you go to stately.ai/editor or state.new, you can use AI to generate machines, and it's free. If you want to generate 3 free machines, you just enter a prompt and it will generate the state machine for you, and it works for XState version 4 or version 5. And so it wasn't so much fine tuning, but rather we had to massage the data and do prompt chaining. And that prompt chaining actually resembles the state machine itself. But the prompt chaining makes sure that like we have different candidates for like generated XState code, and then we isolate the XState code. We make sure that the code is valid, and then we convert it to a directed graph format that Stately can understand. And that's not fine tuning, but it's the next best thing, which is prompt chaining. So yeah. Honor says, going back to my question from the start of the webinar, say you have a component that has fallback functionality if the actor that is spawned by the parent process has not been initialized, like the actor path notifier needed to be optional. Okay, so let's say, yeah, that's a good idea. So I am going to, just to show this, actually, I'm going to make a different component. So I'm just going to say this is, let's see, function feedback value. And all we're going to do is select that value. So use selector actor. And this is just going to be s.context.feedback. And then we're going to return or sorry, this is going to be feedback value or that. So again, this is a contrived example, but if we have feedback value and we pass in the actor over here, you see how we're getting that? This is a completely different component just reading that actor. Now, the original question was, what if this was undefined? Or actually, let's make it optional. And let's say that we didn't pass anything in here. Now, this should still, oh, I don't set the latest XState. So PMI XState React latest. If you have the latest XState, XState React, then this should work. Let me see what's happening. Oh, so because this is undefined, this might also be undefined too. So now it's just going to work. So yeah, hopefully that answers that question, where now the actor can be optional in useSelector. But just keep in mind that when you do that, the snapshot might also be undefined. So you just have to keep that in mind. Another history question. If I have a deep history state, am I allowed to put it inside a parallel state so that a transition to it will make all the child parallel states go back to where they were? This means that if the history state itself is one of the parallel states, I don't know where else to put it. So this is another feature of state charts. And just to answer your question quickly, this should be in the docs. If it's not, then let me know and I will update it. With your history state, it's going to basically tell you, go back to the most recent child that you were at. So step 1, step 2, step 3. With parallel states, you might have children and grandchildren, so you might have a deeper nesting. And so to have a history state target those deeply nested states, you just do history. Oops, if I spell it right. History. By default, it's going to be shallow, but if you set it to deep, then it's going to recursively go to the most recently visited child or grandchild or descendant child state. So that is what you need. History deep. All right, Thomas asks, do you test your state machines, your actions, anything else? I do, we do. And so we do get this question a lot, like what is the best way to test state machines? And the funny thing is that state machines make it easy to test your logic, but it also makes it unnecessary because a lot of the times you're not, like you're testing what XState already tests. Like if you have a transition like on state A, event E, you end up in state B, you really don't need to test, like, if I'm in state A and event E happens, then will I be in state B? Like, those are things that XState already tests in the library itself. So, it doesn't really make much sense to. However, I'm going to show you, in the XState repository itself that, we do have, these tests. And also, it does give you a good idea of how you could write your own state machine tests. So let me just go to this real quick. All right, so in the XState repo, you're going to just navigate to packages, core, and this is if you really, really want to get deep into it. But we have a lot of tests over here. And so let's go to, for example, this deterministic.test.ts. So in our test, we would have a machine that we create. Can't code fold in here. And there's a couple of helpers. This is available in XState itself, but we have getNextSnapshot, and we have the current machine, the events, and a specific state. And we want to make sure it reaches a specific value. However, there's other, let me see if I could find some good ones here. Oh, okay. So one of the ways that we tend to do the tests is first we define the machine or the actor logic, and then we create an actor from that and we start it. And so based on that, we could actually send it events. And so when we send it events, we're going to just assert that the correct thing has been done. So either it ends up in the correct state, or it's it executes the correct actions. So that's a way that you could test your your state machines as well. Hopefully that helps. And we'll have more documentation on that. I know that we're light on documentation for that, but it's something that we'll hopefully add soon. All right, let me go back to my VS Code, just somewhere over here. Sorry, my Chrome is struggling with the 100 tabs I have open. Okay. All right, so answering a few more questions. Let's see. Where was I? I'll add this back to the stage. I guess I'll go backwards. Is there any best way to handle React Router and XState? This is a good question. So in general, and we'll make more detailed guides on this, but in general, what you could do is if you're using a state machine to define like a step in the process where the step in the process might not be the initial state every single time, but you might want to do something like read it from query parameters or like read it from persisted storage or something like that, then what you could do is if you have that persisted state somewhere, persisted snapshot, then you could just provide that directly inside of, for example, the hook over here. So you could say snapshot and then, some persistent snapshot. So in fact, we could just do feedback machine dot restore snapshot, and then like this is your snapshot value. So value. Yeah, so this is something that we definitely have to write a guide on, but long story short, and there is actually documentation on this too, but long story short, yes, you can set the machine to a specific state and say you should start at this state. And so that way you could read information from the router or from query parameters or something like that and tell the machine to start at that state. Now, you shouldn't use it to control the state machine and say, hey, you should be in this state, now you should be in this state, because that's the job of the state machine. But otherwise, yeah, you could just read information externally and turn that into a state that the state machine should be in. Let's see, Javier. Thanks, David. That was clarifying. I take the spawn actor would have persisted inside the machine children for its runtime independently of the current state machine. Yes, so that's exactly correct. If you give a spawned actor an ID, and all this is in the documentation, a little bit more advanced XState, but then yes, it is going to stay in states.children until you decide to stop it, and then it will remove it from there. When I have nested children, I often provide to them the same stuff and input from top down as props in React. I'd have to see an example of this, but I believe that this is okay. So yeah. All right, so we're almost at time, and what I want to do now is just answer any other questions that you might have, and also I want to share a few resources. So let me just go to my browser real quick. Okay. So first of all, you could find a lot of information in the XState repository itself. So there's documentation. There's also the stately editor. I should actually share my screen. There's also the stately editor, but something that I briefly mentioned before, if you go to state.new, this takes you to our free visual editor. This is a place where you could actually create these state machines visually. So let's say that I wanted to, create a new machine. We could just open the starter template, which just gives you a lot of good information on basically how to work with this state machine. It does provide a lot of basic starting points for you, so you could just use it as an example. For example, we have these guarded transitions over here. We have a reset action, and we have some nested states. And you could also click simulate and click through these. And this will give you a better understanding of how state machines actually work. And then you could do things like add more states. So we could drag over here, do that, add events. We could add actions. You could even edit these actions in code over here. There's some quick ways to define custom or common actions like assign, raise, send to, etc. And then when you're ready, you could click code at the top left, and I should really zoom in. And then you could actually export this. So you have all this code where you could copy it over and use it directly in your code base if you want to. Now, you could also go the other way around. So if you have an XState example, like I showed you before, you could just grab it. And it doesn't matter if it's XState v4 or v5. I'm just going to grab a random one over here. You could import it, paste it there, and import that XState machine. And this is a very simple machine, but this just gives you an idea. You could copy paste your code to easily visualize your machine. So here's some more example machines I made. There's also a lot of other features too. So for example, you could use AI and actually generate a nice little summary of your machine, just so people could understand how the machine works, what it's for. And there's also test generation. So we could generate test paths, which actually works pretty fast. So, and this is using XState test behind the scenes, which is the subject of a whole other workshop. But this will actually generate just test code that you could use so that you could fully test your state machines and transitions, which is really, really useful for end-to-end tests. In fact, most of the generated tests do not use XState at all. So you could even just copy and paste this and use it directly in your test code. So it's really useful for authoring tests. But yeah, what you could also do is you could export to things like JSON if you're consuming the state machine in something other than XState, or even things like Mermaid, which sometimes works. Mermaid is weird with its syntax, so it might not always work. It might work for simpler examples. Let's see. Nope. That's why it's in beta. But yeah. And you could use it in XState, or sorry, in XState version 5, and XState version 4, and things like that. So yeah, we also have a lot of documentation. So basically everything I talked about today and more is in our documentation. So I really encourage you to check it out. If you're coming from XState version 4, then we have an extensive guide on going from XState 4 to XState version 5. With examples too. So it should make the migration process pretty easy. By the way, this seems long because it's going through every possible thing you could do in XState. If you have simple machines, then the migration process is actually very, very quick. Again, there's a lot of examples. We even have cheat sheets and basically all the docs you could want for anything that you could do in XState. So yeah, our Discord community is at discord.gg/xstate. I'm always there answering questions. And yeah, thank you so much for joining this webinar. If you have any questions or comments, then please feel free to leave them in the comments of wherever you're viewing this on Twitter, YouTube, or even StreamYard. And yeah, join us in our Discord, come chat with us. And I'm always looking forward to hearing your suggestions and feedback. So please let me know. Thank you all very much for joining me.